All right, this is finding the value of a polynomial function, also known as evaluating an expression, but for algebra functions. So what we're going to do is we're going to see that we can evaluate first and then add, or we can add and then evaluate. And that's the long and the short of what we're doing in this section. So in this first part, I'm going to take it quite as a literal interpretation, f of 0 plus g of 0. So I'm going to find f of 0 first, which means, right, find the value of this polynomial function. So 3 times 0 squared plus 4 times 0, and then minus 2. And that is going to be 0 times 3, which is going to be 0, and 4 times 0, which is 0, and then plus a negative 2, which is going to give me a negative 2. And here, this is going to look like 2 times 0 squared minus 2 times 0, and then plus 5. And then that one, of course, 0 squared is 0, 0 times 2 is 0, 0 times negative 2 is still 0, and then plus 5 is 5. So now I have the value of f of 0 and I have the value of g of 0. So f of 0 is negative 2 plus g of 0, which is 5, and negative 2 plus 5 is positive 3. Now we're going to take this literally as in the second part here, as evaluate the sum first and then evaluate it at x. So this one says add the two polynomials together. So I'm just going to put a line under here and say we're adding these, right? Stack the constants, stack the x's, stack the x squareds. So the sum of x plus g of x is going to look like 3x squared plus 2x squared, which is 5x squared, and then plus 4x minus 2x, which is 2x, and then plus negative 2 plus 5, which is 3. Now that I have f plus g of x in general, now I can evaluate f plus g of x at 0. So this says 5 times 0 squared plus 2 times 0, and then plus 3. And 0 squared is 0, 0 times 5 is 0, 2 times 0 is 0, 0 plus 0 plus 3 is equal to 3. And what you see is that it didn't matter if we evaluated each of the functions at 0 and then added them together, or if we added the two functions together and then evaluated them at 0, we got the exact same value. And that's a very important thing to learn because we can use this to evaluate the sum of two functions on a graph with tables. We can do it with ordered pairs. We can do it with functions, as long as we know that these two things are exactly the same. So what we want to understand is that either way we go, we're going to be able to find the sum and the value of a sum at a certain value. So for instance, one of the things that I might do here is I might say, okay, well, I have these functions. I have my f of x function here, and I have the x values here and the y values here. And so maybe I have 0, 1, 2, and 3, and maybe I have 2, 4, 6, and 8. And then I have my g of x function here, and maybe I have this at x and y, and I have 0, 1, 2, and 3 here, and maybe this one's 3, 5, 7, and 9. And so if I wanted to find what f plus g of 1 would be, that would mean that I don't have this sum function, but I know that that's the same as f of 1 plus g of 1. And that I can certainly find. Remember, these are the y values. So f of 1, that is the 4 value there. And then plus g of 1, well, that's the 5 value there. And so I can see that that's 9. And that's why it's useful to be able to do it both ways. And the same could be true if we put these on a graph and we can look at two graphed functions. Remember our rule of 4s. And that is the value of knowing that f of x plus g of x is the same as f plus g of x.